Good morning, Prep 4. This is a maths video for Friday of week 2. And in today's lesson, we are going to be looking at sorting triangles. So let's get started with the learning reminders. We've done a little bit of work on triangles already this year, so hopefully this will be a recap of learning that you will already know. So describe, name and sort triangles, identifying their properties. So this is triangle 1, and triangle 1 is called an isosceles triangle. Can anybody remember how we identify an isosceles triangle? The way I remember it is I think of the isosceles, the I part at the beginning of the name. We have two eyes. And an isosceles triangle will always have two sides that are of the same length. That's what makes it an isosceles triangle. Now, the name actually comes from the Greek, which means iso, which is the same, and skelos, which means leg. It has two equal sides and therefore are two isosceles sides and one line of symmetry. Triangle 2 is called an equilateral triangle, and I think its name speaks volumes. The equilateral triangle means all sides are equal. They are of the same length. And if you remember the learning from yesterday, that makes it a regular shape. Equilateral triangle has three equal sides and therefore three lines of symmetry. Have a think about this question. What is the same about triangles 1 and 2? So can you think of any similarities? Can you think of any differences? Okay, next page. We have two more triangles. Triangle number 3, triangle number 4. Triangle 3 has a right angle and it has two sides. Now, as it has two equal sides, it could be an isosceles triangle. But, and back to yesterday's right angle measurer, it has a right angle, and I'm just going to check that by placing my right angle measurer into the corner, and yes, those lines meet up exactly. So we call it a right angled isosceles triangle. You can just get right angles which don't have two sides that are of the same length, but this one does. Number 4 has two equal sides, therefore making it just an isosceles triangle. Okay, it has one line of symmetry here. What is the same about triangle 3 and 4? So can you think of any similarities? Can you spot any differences? Have a think. Okay, and finally, triangle number 5. Now, it doesn't have any lines of symmetry. It doesn't have a right angle, and it doesn't have any sides that are of the same length, which means it is a scalene triangle. So any triangles that have sides of different lengths, different angles, no lines of symmetry mean that they are a scalene triangle. So try drawing another scalene triangle. 1, 2, 3. That would be a scalene triangle. See if you can have a go at drawing a scalene triangle. So your practice sheets for today, you have mild or hot options. They're quite similar though. So just choose one to complete as some are repeated. So use a set square, that means a right angle measurer, which I've got here, to check if each triangle has a right angle. If it does, mark it on. And the way we mark a right angle, now I haven't got a ruler, I'm being very naughty here. But if I was to draw a right angled triangle like this, the way we would mark the right angle would be this, and this shows us that that is a right angle. That angle is 90 degrees. Write the name of each type of triangle and then write 2 facts about it, so 2 properties. Your facts could be related to the size of angles, the length of the sides, how many sides are of equal length, if there are any obtuse, any acute angles, if there are any lines of symmetry, anything you would like. So, for example, the first one, I can see here that this must be 2 sides of equal length. It must be an isosceles triangle, so I would write isosceles triangle there. My 2 facts could be that 2 sides are of the same length, And I know, I can see here by using my right angle measure that is less than 90 degrees. That angle is less than 90 degrees. And that angle is less than 90 degrees. So my second fact might be that it has 3 acute angles. Okay, there are answers for you to have a mark of yourself. If you're a bit stuck, we have what's special, and it's an activity that involves you cutting out these triangles here and then placing them into this Carroll diagram. So you will be looking to see, first of all, if the triangles are symmetrical or non-symmetrical, if they have any lines of symmetry. If they do, they will fit in this box or this box. If they don't, they will fit in this box or this box. And then you are looking at if the triangle has a right angle. You will need a right angle measurer to do that. If they have a right angle and they have a line of symmetry, they will fit in here, and so on. Have a go at that if you're feeling a bit stuck. If you're not stuck and you want to have a go at it anyway, that's absolutely fine. And then to end today's lesson, to end maths learning for the week, draw triangles to match each description, and then finally make as many generalisations as you can about this collection of shapes. I meant to mention with the practice sheets, you don't have to print out these sheets. Obviously you can if you would like, but you could just copy the triangles into your maths exercise books and then write the names and the properties underneath. Okay, so you don't have to print them out. Enjoy the learning, guys.